So let us say the area of the rectangle required is of 120 mm square. So this should be calculated based on what? The length or the width. So let us specify the length. By default it's in length, yes. So what is the length of the rectangle? Say it's of 52 mm. So based on the area that we have entered and the one of the dimension, that is the length, the other dimension is plotted and the rectangle is plotted. Let us just quickly have a look at this object, or rather let us invoke the quick properties menu and see about this. So you can see here the area is 120 and the length is 108. So this is based on the input. So the length, so this is the 1 minute. So we can do a quick measure and see the length is 52 mm that we have specified, and hence the width is 2.3. So this is the actual measure that we had entered it. Right. So this length is the circumferential length. So it's the peripheral length. So the sides are 52 mm and the width are 2 mm. So totally 108.6 is the total length that is showing in this quick properties. So this is one way of doing with respect to the area. Let us look into the other one, that is specifying with dimensions. So now we'll give the absolute dimensions. So the length will be 52 and the width will be say 5, and you'll get it based on the start point. Remember our start point was here, so based on the position we can interchange it. So now the third part is rotation of the rectangle. So we can specify which angle it should be. So rotating angle, let us say, is 45 degree. So once that angle is fixed, next we can proceed on to say what is the end point or the area or the dimension. So these are the different ways by which we can draw a rectangle. So next the part is the drawing of a polygon. So polygon can be invoked by the command POL. So the first prompt is the request for the number of sides of the polygon. So by default the number of sides is prompted as 4, and we can choose whatever we want. Suppose the polygon has a side of 8, and then specify the center of the polygon or edge of the polygon. We have two options. So going on with the default option of center, by picking the center of the polygon, then comes the two selection criteria, whether the polygon is inscribed inside a circle or circumscribed about the circle. So these two are imaginary circles about which the polygon is going to get constructed. So if we go in and go by the default of inscribed in circle, the radius of the circle is asked for. Let us assume the radius of the circle is 15. So now this polygon is inscribed within a circle of dimension 15. So this you can very well see by looking into the height of the circle. So let us draw a circle to be sure. So let us control click and then find the geometric center. So now let us look into our inputs. So what we have specified is the radius of 15. There you go. So now this polygon has been inscribed within the circle of radius 15. So this helps us to eliminate this process of drawing a circle and then inscribing it with it in it. So this is the process of creation of a polygon within a circle, inscribing in a circle. So now we'll go and create the same polygon of 8 sides with specifying the center but circumscribed about the circle. So we'll specify the radius of circle 15 again, and now we can see that now the circle, let us also draw a circle to quantify it. Again control and right click to select the geometric center of this, and then the radius of the circle is 15. As you could see, the polygon is drawn over and above the circle. So this is the circumscribed operation, and let us also show this inscribed circle to show you the difference between it. So the polygon is inscribed within the circle in this first command and outside the circle in the second command. So this is the way of constructing a polygon. The next way is again the polygon command, but with the edge. So supposing let us have a surface, say with this orientation. Remember, we had given the direction as 45, so it remembers the same orientation. So now let's say the polygon edge is aligned with this line. So we can make use of the command of edge to specify the edge point of it. So assuming it is figured out in this edge, so you can select the edge point, thereby you can control the dimension of the polygon. So these are the different ways of executing a polygon. So next one is the polyline command. So why we have kept it at the last? Because one thing you can observe here is whenever you click on the rectangle or the polygon, always it shows as a polyline, because internally it gets constructed through a polyline methodology only. So now let's look into the polyline method. So polyline is that you can draw a line as well as extend it to a polygonal arc or an ellipse based on the requirement. So it combines a line, a circle, arc together. So in order to simulate this, you can type in P-line for polyline. So it will start off as a line. The initial command is the same as a line, but once you have specified the point, before the next point you can also have the option called as arc, half width, length, undo, width. So let us see one by one. So let me keep on drawing the line. So this is same as in line command. The command gets continued unless you are terminating externally. Next you can extend it through the arc command. So once you click on arc, your arc modules get included here. So whatever the first point that you have given will be the start point. Next it expects a second end point, whereas you can also specify the angle or modify from the end point to the center point, and then based on that selection you can go for example, if you go for the center point, then you get the other options what you had seen earlier in the arc. That is, you can either specify the end point directly or specify the angle or the chord length and so on and so forth. So remember, until you stop it, it will keep on executing. And suppose I'm specifying with the radius of the arc as say 33, and with this dimension I'm using control key to vary the dimension. And okay, 55. So with this, now I intend to close the circle. So with this, what we can do is type in CL, and the AutoCAD does the closing operation by itself by connecting back to the original one. So this is a faster way of doing a drawing. Suppose if you are very clear about the nodal points and the dimensions, then you can keep building on it and then quickly figure it out instead of going by separate commands for line, circle, arc, merging and all these things. So this is a powerful command that once you get mastered, then you won't be going to other commands, individual commands, but rather work on this itself. So this is to sum up all the drawing commands that we have seen. So let's try and replicate this drawing that we have seen in the screen. So this is a spacer element, an assembly element, which also have hexagonal nuts bolted onto it. So here what we can see is the spacer element is of a major dia of 150 mm and the through-hole dia is 90 mm. So these bolts are M8 bolts with a pitch of 1.25, and there are 8 bolts EQ spaced on a pitch circle diameter of 120 mm. So let's try and draw this onto this AutoCAD environment. So to start off with AutoCAD, let us specify the limits and the units. So first let us enable the limits, turning it on and specifying the lower corner of 0 and 0, and let's specify the upper corner, say for an A2 size paper where we typically draw the engineering layouts, and so it has a height of 594 and a width of 420. So we'll keep the same dimensions, 594 and 420. So now we have set the limits of this model space based on a A4 mm diagram. And next let's invoke the units, and so we are operating on millimeters, and let's keep a precision of 2 units and in degrees only. So we have updated the system command units to millimeter. So always ensure that you have specified the limits of your model space and limits as a best practice, so that you don't miss out during the layout publications and so. So now let's see how we can draw it. The drawing has been hosted in this bottom right corner, so that you can have a quick reckoner when you're following this video. So first off, let us start and draw the spacer. So the spacer outer dia is of 150 mm. So let's start with the center point of here, and then stating the diameter as 150 mm. Let us zoom a little bit to accommodate it, and now draw the inner circle. So we need to snap to the same point, and then choose the diameter again and specify as 90. So that's it, we are done with the spacer element. Now let us draw the hexagonal nut. So to start off with the nut, the dimension required is M8 bolt with 1.25 pitch. So this M8 is a metric measurement of nut. So nominal dia of this nut will be 8 mm, and so the across flat. So let us quickly show you how it's going to be. So the hexagonal bolt will be of size 6, and let's say this is the center of the polygon. Okay, so let's give within the limits here, and so the bolt typically will be inscribed in the circle. So let us quickly draw one hexagonal bolt like this and look into the terminologies. So typically this face and this face is called across flats, wherein you put in your wrench to tighten the nuts, whereas this edges from this to this is called across corners. So these are the two terminologies that you can describe the hexagonal bolt or nut. So here then you have the through hole that is going to come into it. So let us go to the geometric center, and also let us draw one more circle to show that. So this is an inscribed circle, because basically you are chamfering out the edges of the nut. So this is the representation of your hexagonal nut, and you have to also showcase the nut specification, the inner dia and outer dia, by virtue of the screw element. So the nominal dia of the nut will typically be hidden because it's the bigger one, whereas the smaller edge is what is being visible. So the typical nomenclature is that for an M8 bolt, the outside dia, that is across corners, would be typically 15 mm of dia. So when you are drawing a polygon, so you have to make sure that you are inscribing it. So typically what means is this across the corners, so this circle should be of dia 15 mm. So that will quantify this M8 bolt. And then we have drawn the nominal radius, but we'll draw the minimum radius. So typically the minimum radius is 0.85 times of the nominal dia. So to quickly open up the calculator, let's see here, 0.85 times of 8 mm of nominal dia will be 6.8. So the inner circle would be typically of dia 6.8. Okay, so let us draw this onto our model. So the requirement is a polygon and it has to locate here. So the number of sides is 6, and so we have to position it from here. So the requirement is it should be located on a pitch circle diameter of 120 mm, so that its radius is 60. So you need not draw a circle and then inscribe onto here. What you can do is again control and right click and give in the distance from. So select this point and then use your coordinate system referencing to say that at the rate of 60 units at an angle of 90, so that will get pushed in there, and as we had seen earlier, it's going to get inscribed within a circle of across the corner dimension of 15 dia. So the diameter of the circle, so as the radius, so it is 7.5 mm. So this is your bolt, and now let us draw the nominal dia, and we'll pick up the geometric center, control right click on the geometric center of this, and then specify the radius or the dia as 8 mm. And now also let us draw a circle that is inscribed within this to specify the, let us zoom a little bit to do. Okay, let us specify the midpoint here to draw the chamfered edges. So now this would be hidden bolt, and now let us draw the minor dia. 0.8 times of 8 6.8 dia, and now as a representation we have to trim out the other quadrant. So to do that, let us use the break command, and selecting this object, specify the first point as an extension to here and the second point as to here. So that's it, we have got the bolt, hexagonal bolt. So now let us use the array command, the polar array command, to replicate it. So we give the array polar, and the objects are these. So the center point of the array will be the circle, and the number of instances will be 8. So that's it. So with this we have drawn the flange plate, the spacer element with the bolted hexagonal nuts. So now we'll have a recap of the session that we had today, the lay of the land. So what we have looked at is different drafting settings, the object snap commands and polar tracking. Those commands have also been replicated in the last exercise that we had. So this will help us a lot in accelerating our drafting process. And next also we looked into the dynamic inputs that are available to us and how we can circumscribe from the absolute to relative polar and henceforth. So by using comma, at the rate of, angular and pound symbol. So by this also we can get a floating tooltip of what is expected next out of that command. So those comes in the dynamic inputs. Then we looked into setting of limits and setting of units of the entire model space, and next we had a look at the options that can be designed to suit our needs, customized based on our needs. So after this we also had a look at undo and redo commands. Next we looked into different editing fundamentals, move command, the copy command, array command, the rectangular array and the polar array, and then the break command, mirroring and offsetting. So then we also had a hands-on exercise of a spacer element bolted with 8 hexagonal nuts. So with this we conclude week 2 of the session. So next have a look into the assignments and have a good practice on it. Thank you.